Okay, I think I'll get started because all of you were so incredibly on time. Thank you again for joining me for this workshop. My name is Karen Hao, and today I'm representing the Pulitzer Center in delivering a training on how to cover AI from an accountability lens. You have probably been to a lot of workshops during this conference talking about how to use AI, how to integrate it into your newsrooms, how AI is going to be the future, and if you don't use it, you're going to fall behind. I'm going to provide a fundamentally different perspective. I think there are opportunities to use AI. I think there are also opportunities where we should be running the opposite direction. But most importantly, as journalists, the greatest task in front of us in this AI era is to investigate and cover this technology so that not only can we understand it and better and make more informed decisions for our newsrooms, but we also educate the public, we educate policymakers about how they should be approaching this era as well. This is a course that the Pulitzer Center and I designed together called the AI Spotlight Series. It is completely free. It is traditionally, we've been conducting sessions online. We are also going to completely open source the curriculum later this year. Usually the version that I'm giving today is going to be a condensed version. We usually do a 90-minute webinar. I was given 50 minutes. I'm going to try and power through like 75% of the curriculum in this shorter time. But if you become excited about learning more, please do go to the Pulitzer Center and look out for when we open source the curriculum fully and in all of its different variations. Part of the reason why we decided to design this course is because I've had many journalists come up to me over the years. I've been covering AI for around 7 years now, first for MIT Technology Review, then for the Wall Street Journal, and now I freelance for publications like The Atlantic. And many journalists have come up to me believing that to cover AI requires some kind of unique specialization, some unique technical knowledge that is sort of inaccessible to the average journalist. I fundamentally disagree with this. I think AI is a story that any journalist can cover. If you think about any beat that any of us tackle, it all requires specialized knowledge, and ultimately we all end up learning that specialized knowledge to then be able to deliver newsworthy stories to the public. And so really AI is actually at its core one of the most canonical beats in journalism. It is doing what journalists have been doing forever, which is unearthing human stories, documenting change and transformation, and holding power accountable. So I hope that this session will convince you of that, and it will also convince you to become an AI reporter tomorrow and start incorporating more of the things that we talk about today into your ongoing coverage, whatever you cover from wherever around the world. So, So what we're going to cover today, I'm going to give you a brief and incomplete history of AI, then a framework for how to report on AI through an accountability lens, a very, very quick introduction into deep learning and generative AI, and then hopefully we have time for a deep dive into 2 stories, AI accountability stories, and a framework for using AI in journalism. It's a lot to cover in 50 minutes, and I will also try to leave time for questions at the end, so wish me luck. So I'm going to start with a history of AI because I really think it's helpful to understand where AI comes from in order to know what is happening today. And I want you to keep this in mind, that the story of AI has always been about ideology, money, and power. This is not just a technology story. It is at its core a human story, a system story, a politics story, and a story about power. So those are the 3 lenses through which to understand how AI became what it is today and how it continues to impact people and communities all around the world. So let's start with a definition. What actually is AI? Well, there's a common misconception today that AI is only one thing, and that's because the world was introduced to AI through ChatGPT. So there is this notion that ChatGPT represents the entire landscape that is all of AI, or that AI is solely ChatGPT. And in fact, AI actually is many different technologies that are all kind of loosely tied together with one commonality. They're designed to mimic human capabilities. And I like to go one step further and say AI is specifically a name for many different technologies. And I'll explain what I mean in a second. But I think making this distinction is really the first step to disentangling the reality and the hype of what AI is today. So what do I mean that AI is a name? So the term artificial intelligence was first coined in 1956 as a name for a discipline at a Dartmouth University summer gathering in the US. And it was introduced by this guy, John McCarthy. McCarthy was an assistant professor at Dartmouth University at the time, and he was working on research to build so-called logic machines. If you've ever seen The Imitation Game, the movie, it talks about Alan Turing and his effort to build logic machines during World War II to crack the Nazi Enigma code. And that is essentially what McCarthy was also doing. He was trying to build these big hulking apparatuses that could do complex computation to crack code, solve math problems, and things like that. This was not originally called artificial intelligence. It was called automata studies. But no one gave a crap about a discipline called automata studies. And so McCarthy, in looking for a better term to appeal to funders, to scientists, and to the public, decided to come up with the name artificial intelligence. It sounded a lot sexier. It suddenly gave a lot more attention to the same exact work that was being done under a different name before. So artificial intelligence was a marketing trick from the very beginning, this phrase. And it worked really well. And not only did it bring more attention to this budding field, it also ended up reframing the way that scientists themselves thought about what they were doing. They were no longer building machines just to solve math problems. They were trying to recreate human intelligence. And this has become a really guiding ideology in all of AI development all the way up until present day. And that is why you see companies like OpenAI, Anthropic, and now increasingly also the major giants, Google, Microsoft, adopt this kind of language where they are recreating a new form of intelligence. They're recreating potentially a new species. They use really stark language like this to try and convey the grand quest that they are on. But the problem is AI has always been a really ill-defined term. So Marvin Minsky, another founding father of AI in this photo, he used to call AI a suitcase word. You shove whatever meaning you want into the suitcase and suddenly AI means something different. And part of the reason why is because scientists have radically different opinions about what it would take to recreate intelligence. So there have been heavy disagreements across the decades about what AI should look like, about what technologies we should use to achieve it, what purpose it should serve, and importantly, who it should serve. And over the decades, what we call AI has really changed a lot. So the technologies we consider to be AI today work completely differently from what was considered AI in the past. That said, there has been a central dominant paradigm that has defined each era of AI for what it should look like, how it should work. And that is really based on who has had both the money and the power to push their particular vision of artificial intelligence. So in the early days, what was the dominant vision of AI? One example is this system in 1964 called ELIZA. And it was devised by an MIT professor called Joseph Weizenbaum. And on its surface, it actually looked a lot like ChatGPT. It was a chatbot that you could chat with, except you chatted with it with a computer the size of a room this big. And you would chat with it with a typewriter. And Weizenbaum designed one instantiation of ELIZA to specifically try to mimic psychotherapy. Under the hood, it worked completely different from ChatGPT and other chatbots today. It was a system that simply followed a set of hard-coded rules. So you would say something like, "Hi, Eliza, I'm feeling down today." And it was hard-coded to reflect back to you, based on a method of psychotherapy, the key words of what you said. So it would say back, "Why are you feeling down today?" "My friend said something mean to me." Do you think that it's normal that your friend said something mean to you? Obviously, this is a very simple system, and it's very clear and transparent what it is actually doing once you pop open the hood. But people found this simple system incredibly impressive. They thought that this was the end of human psychotherapists. And computer scientists were predicting that artificial intelligence was just around the corner, we were about to solve it, we were about to crack it, and that everyone was going to be using chatbots, and that was going to be a couple years away. So this rule-based way of developing AI became the dominant paradigm for AI. Everyone started developing rule-based systems and calling it artificial intelligence. And there was this belief within the industry, within the field, that if you could just encode more and more complex rules into a computer, you would then recreate all of human intelligence. So that is nothing like how ChatGPT works today. There are no hard-coded rules dictating what ChatGPT says back to the user. Instead, it's a statistical engine under the hood, and it's being trained on vast swaths of internet data, computing patterns of language, and still reflecting back to the user what the user said to it, but this time with statistical correlations that allow it to construct new sentences. And now people find ChatGPT really impressive, and they're also saying this is going to be the end of human psychotherapy. This is going to be the end of human teachers, the end of human doctors. And it's the statistical engines that have become the dominant vision for AI, and everyone in the field and everyone in industry is now racing towards developing these chatbot systems using statistical technologies and saying that we will, right around the corner in a couple years, recreate human intelligence. And what's more, there's now a new term on the block, and this is artificial general intelligence, which is a term that OpenAI popularized when it was founded in 2015. And that's supposedly the new name to refer to human-level intelligence in computers. Wait a minute, I thought AI was supposed to refer to human-level intelligence in computers. AI has always been a marketing game. So now, because AI has become cheapened as a term, we need a new term that sounds sexy and exciting, is going to attract a lot of funding and public attention. And so now artificial general intelligence is the term du jour. And we are now supposed to believe the way that Eliza became associated with AI, we are supposed to believe that ChatGPT is somehow going to bring us to AGI and to recreate a fundamentally new form of intelligence. So the dominant vision of AI has shifted from rule-based systems to increasingly big data, big compute systems. And what does big data, big compute mean? So data here refers to mass scrapes of the internet, as I mentioned. And compute is a technical term within the industry that essentially refers to raw computational horsepower. How big, how fast, and how powerful is the computer that you are using to develop your AI system. And this is the formula that now drives modern day AI development. In the statistical engine era of AI development, there's this belief that if you put more data and you have bigger computers to develop a single AI system, that you will somehow get closer and closer and closer to AGI. Why has the vision actually shifted from rule-based to big data, big compute? It comes down to who is developing the technology. So in the early days, it was academics that were leading the charge, scientists, and they were funded by the government, and they were funded by foundations like the Rockefeller Foundation. And they were working on a relatively shoestring budget compared to what is being used today. So scientists were really focused on the academic, scientific nature of things. They were trying to explore philosophical questions, and they were trying to develop very efficient systems because of the limited budget that they had. In modern day, it's big tech companies that are developing these tools, or some startups that are overpriced right now, and they're using their own funding. These companies have massive troves of data, which is a huge competitive advantage if they can create AI systems that are trained on data. They have boatloads of cash to buy massive supercomputers. And they're motivated by commercial viability like generative AI applications. And so that's why we are seeing this shift from one to the other over time. So this new dominant vision has propelled a rapid escalation in the amount of data and the amount of compute being used to build AI systems. So this is a chart of the amount of data being used to train a single AI model. And you can see in more recent years, the amount of data that is being used in systems today completely dwarfs the amount of data that was used for systems of the past. It makes it look like systems of the past were not trained on data at all. And the same story goes for compute, which you can see just from the trajectory of OpenAI's technologies. The parameters of an AI model on the slide here, that's a proxy for the amount of data and the amount of compute being used to train a single AI model. And in 2019, GPT-2 had 1.5 billion parameters, which at the time was the largest AI model. In 2023, 4 years later, GPT-4 reportedly had 1.8 trillion parameters. So what we can gather from this is compute increased roughly 3 orders of magnitude in 4 short years. And what that means in practice, whereas AI models in the past could be trained on maybe an extremely powerful laptop, AI models today, like the ones companies like OpenAI are building, specifically generative AI models, chatbot-like systems, they require supercomputers with tens of thousands of computer chips crunching numbers for the order of months, nonstop. And that means a lot of energy. That means a lot of heat, a lot of noise pollution. These supercomputers are also using water to cool down the overheating of their systems, so they're using drinking water, and that happens for months on end. And of course, OpenAI and other companies aren't stopping there. Earlier this year, you might have seen that President Trump announced a new joint venture between OpenAI, SoftBank, and Oracle to pump $500 billion in over 4 years of private sector investment into building more and bigger data centers and supercomputers for OpenAI. And to put that into context, the Apollo program, which sent the first man to the moon, cost around $300 billion of today, over 13 years. So $300 billion over 13 years to send a man to the moon, $500 billion over 4 years to somehow bring us bigger chatbots. So all the companies are pursuing Gen AI on this similar trajectory now. They're all kind of adopting OpenAI's playbook and chasing OpenAI's tail, and all trying to feed more data and more compute into these systems. So we have ended up in an era of limits, where the vision that generative AI is leading us towards is so resource intensive that companies are running out of things to feed this AI development. They're running out of text on the internet, they're running out of computer chips in the world, they're running out of energy on the grid, and increasingly they are running out of fresh water resources to draw from to cool their supercomputers. So this, just as a reminder, is the vision of the future being dictated by the wealthiest companies in the world. This is why we are at this point. And of course, they have this vision. They are the only actors in the world that get to participate. So it's a phenomenal way to lock in their competitive advantage. No one else has these resources at their disposal. And I should add, I used to have Chinese companies on this slide as well, but due to US government actions over the last few years, Chinese companies can no longer get access to the world's most cutting edge computer chips. So they're no longer operating in the kind of same game. Which has actually then forced them to take a different approach to AI development. And this is a really critical dimension for thinking about how AI impacts your country, your community, your context. Many of you are probably joining from countries that do not have the resources of these dudes. And that means many of the generative AI technologies that you're going to interface with are exports to your environment. And you really need to think about it from that perspective of these technologies are imbued with certain assumptions, certain values, certain ideologies from a very small group of people, and that those assumptions might fall apart when they actually interface with real people in your contexts. So we should examine as journalists, does that actually serve these people, your communities? Where does it fall apart? Who benefits and makes money along the way, and who is harmed in the process? I'm gonna skip this slide because it takes a little bit long and just get straight into a framework for AI reporting. Okay, so what the history of AI hopefully has showed us is what I said from the beginning, that a critical lens for understanding AI development today is power. And so for the AI Spotlight series, we designed this framework for how to think about identifying and framing AI stories with those power dynamics in mind. So let's start with thinking about the different stages of modern AI development. As we mentioned, modern AI is now a big data, big compute game. So you have your data, you have your compute, it's going to go into training an AI model, and those AI models will then be fashioned into applications that are deployed into real-world contexts. So this is basically the supply chain of AI, if you will. And at each stage of this supply chain, there are critical issues that we want to investigate, there are actors that we need to hold accountable, and there are people and communities that get affected and harmed along the way. So there are examples of stories that you can cover in each of these columns, and I will run through some quick examples, and then we'll dig deeper into some specific ones. So when it comes to data and thinking about the data part of the supply chain, it's important to ask who's actually amassing that data, and who is that data coming from? How might that scramble for data lead to a loss of privacy and consent, a perpetuation of surveillance, an erosion of intellectual property? The New York Times had this really great story that highlights all of these challenges, where they reported on the fact that OpenAI, Google, and Meta are all so desperate for more data for their systems that they're disregarding their own privacy guardrails, they're entering legally gray areas, and they're pushing to erode copyright laws all around the world so that they can continue to have maximum flexibility in hoovering up more data to train their systems. There's also a question of who is preparing the data. So it turns out when you scrape the internet, you cannot just feed that data automatically into your AI system. It's really messy. There's a lot of random stuff in it. It has to be cleaned. It has to be structured, labeled, systematized. And there are actually people who do that work. So who are these people? What kinds of conditions do they work in? And Rest of World had a really great story about how Chinese companies are using vocational school students to do this data work. And these students often do this work, like many other data workers around the world, in very exploitative conditions. When it comes to the compute part of the supply chain, you could investigate the environmental impacts of data centers. For this story, the Oregonian, they were trying to figure out how much water is the data center using to cool all of the whirring of the computer chips computing for AI models. And they actually had to sue the water department to get those accurate numbers on how much specifically a Google data center was using. It turns out it was using 29% of the city's total water consumption, while the city was experiencing a multi-year drought. And here's another story from Manga Bay, where you see the same exact phenomenon happening in Latin America, in Chile, in Uruguay. During significant drought, data centers from Google, from Microsoft are coming in and taking the water, the drinking water that would otherwise go to families. And communities are also mounting significant pushback. So this is another story that you could cover, is the resistance movements that are cropping up all around the world to protest data centers, to demand more transparency around them, to limit the water use and the energy use of these systems. The Washington Post also had a series of phenomenal stories looking at the way that these data centers impact things like the power reliability in communities, power cost, the air pollution, because it means that fossil fuel plants that were going to be retired are having their lives extended to power these data centers. So these can make for great stories in a local context. They also make for really great global stories because these data centers, they often rely on fossil fuel plants, and they are reversing the energy transition right now. And you may have seen the news from last year that Microsoft and Google saw a roughly 30 and 50% jump respectively in their carbon emissions. That was almost entirely because of the data centers they're now building for their AI models. So when it comes to the AI models part of our supply chain, you can also investigate things like the bias of AI models. There have been some really great stories out there, including this one from Bloomberg, which looked into the way image generators really encode harmful stereotypes and actually amplify the stereotypes about race and gender. And finally, of course, I think this is probably the most familiar type of AI story that people see, which is the applications. Like once AI is deployed into the world, what happens? And it's really important to investigate what happens when oftentimes imperfect models are used in the real world. So this was a really fantastic story from The Guardian that talked about how the US government's over-reliance on an AI translation app that failed very spectacularly for poorly resourced languages actually left one asylum seeker stranded in an ICE detention center for 6 months because the app was mistranslating him. And he was unable to meaningfully communicate with anyone, and ICE did not occur to them to actually hire a human translator for 6 months. Okay, now we get to some fun stuff, which is some of the technical details around deep learning and generative AI. Just as a show of hands, who has heard the term deep learning in this room? Okay, most people. Okay, does someone want to shout out what deep learning is?
It's like an architecture of like model building that resembles the human brain.
Yes, okay, fantastic. Okay, so I mentioned in the beginning that AI refers to many different types of technologies, and so I'm just going to give a little bit more history to contextualize why. So when AI was coined as a term in 1956, there were kind of two major camps that emerged around how to actually do this thing that they had decided to do. They have really esoteric names, and you don't have to remember them, but for the purposes of this discussion, they were called the symbolists and the connectionists. Scientists are generally really good at naming things. So why were there two camps? To this day, we have no central scientific theory about where human intelligence comes from. So if you're going to peg a discipline to the recreation of something we do not know what it is, you're going to have very different theories about what to do to recreate this thing. And so the symbolists believed that human intelligence comes from having knowledge. Humans are smarter than animals because we know more things. So if you want to recreate intelligence in machines, you should build what they called expert-based systems with databases of knowledge. And this is where rule-based systems like ELIZA came in, or if you remember IBM Watson playing Jeopardy in 2011, and it was like beating all of the world-class Jeopardy players, that was a expert-based system where it had this huge database of knowledge, and it was retrieving that knowledge on the fly to answer Jeopardy questions. Connectionists believe that intelligence comes from the ability to learn. So we humans are the smartest species in the world because we learn faster than animals, other animals. So to recreate intelligence in machines, you should build machines that learn, and this is where machine learning comes from. And that is specifically software that can learn from data. So deep learning, it stems from the second tradition of machine learning. And it specifically refers to a type of machine learning that uses software called deep neural networks. And as you mentioned, it's sort of this architecture, this software architecture that is trying to mimic the human brain. Because connectionists thought, well, if we want to try and get software to learn, and our brains are the thing that learns, maybe we should take some cues from the way that that evolution designed our brains. I'll get back a little bit into kind of what neural networks are, but Suffice it to say that they are essentially the most powerful kind of machine learning software that there is today, and usually used to process extremely large data sets. And deep learning has now become the basis for many modern AI systems. So here's another way to represent the kind of hierarchy nesting of AI technologies. We have AI, which is our giant suitcase word. And then within AI, machine learning is just a subset of the AI technologies that learn from data. And deep learning is just a subset of machine learning technologies that learn from big data. And nearly all AI systems today are in one of these two categories. Here's how machine learning works, 101, very quickly. So machine learning is a process of using data to create a model. And that data can be anything. It can be your YouTube watch history. It can be your heart rate. It could be something really random like the color of the ocean. Like you can create a data set out of anything, right? You would then take that data set and use a machine learning algorithm to find patterns and correlations in that data. And that then creates your model. This is known as the training stage of machine learning. And once you have that model, you can apply it to a new data set to figure out whether that data set matches the patterns that were learned by the model. And then it'll give you a prediction, a classification, a decision, and this is what's known as the inferencing stage. There are many different types of machine learning algorithms. There are many things that can fit in this yellow box. All of them are based on statistics. All of them. If it's not statistics, it is not machine learning. Some types of machine learning use what I like to say are very simple statistics, while others use very fancy statistics. So really there's like a kind of sliding scale of how simple or fancy you want your machine learning algorithm to be in terms of the kind of statistical computation it does. If you remember linear regression from college math, that is one of the most simple machine learning algorithms. It's just taking a data set and looking for linear relationships, linear correlations in that data. That is a machine learning process. The others use really fancy statistics, and neural networks use the fanciest statistics. So neural networks are like kind of the Swiss Army knife of machine learning software. You can throw massive data sets at it, and it will be particularly good at working with massive amounts of data. It will find subtler patterns within that data, but it also is more energy intensive. It does a lot more computation, and it has one particularly bad disadvantage, which is that they are black boxes. If you have ever heard the phrase AI is a black box, that is actually not true for all AI systems. Actually, every type of machine learning system, except for neural networks, are transparent boxes. You can actually open up most machine learning systems and see exactly how it arrived at its decision. You cannot do that with neural networks and with deep learning because the neural networks do such complex computation that by the end of the computation, all of the different numbers that it's computed and all the different patterns is encoded in zeros and ones and all of these things. It becomes illegible to humans, even to the AI developers who are training it. In the real world, machine learning systems often appear in government AI software. So things like predictive policing, benefits distribution, welfare algorithms. That is usually a machine learning system, a simpler machine learning system that doesn't use neural networks. And a lot of big tech products and services or other tech company products and services, those are the ones that are using the neural networks. They're based on deep learning. So things like your Netflix recommendation algorithm, your Facebook ad targeting algorithm, and other types of things. Of course, it doesn't always mean that everything that government uses is just simpler forms of machine learning. Government also procures AI software from companies. They're increasingly using ChatGPT these days. They're acquiring facial recognition software, which is almost always deep learning. So this is just a general rule of thumb to think about how these systems might manifest in the wild. So the simplicity of machine learning is what makes it so powerful, because you can take any kind of data set and turn it into a model with a machine learning algorithm. You can take faces, turn it into facial recognition. You can take MRI scans, turn it into cancer diagnosis. You can take LiDAR feeds and turn it into self-driving cars. But one of the fundamental problems or challenges with the way that AI has integrated into society is that there are lots of people turning data sets into machine learning models when they should not be doing so, even if they can. So there is a really famous article from ProPublica in 2016 called Machine Bias, and they showed how police departments around the US were using machine learning to do predictive policing. So the software was being trained on historical arrest data, and the machine learning algorithm successfully turned it into a model. But there are two problems. Arrest data is not crime data. There is a significant amount of discrimination that happens in who gets arrested versus who commits a crime. And the second thing is the data is historical. So why should it have any bearing on who is going to commit a crime in the future? So when applying this model, what ended up happening was police departments around the US were basically continuing to over-police communities that it had already been over-policing, because the arrest data just continued to show the people that they were already arresting in the past. And so they found that there was significant discrimination where one black defendant and one white defendant had committed, the white defendant had committed a much more egregious crime, but the black defendant got a much higher risk score, where they were told, the algorithm told the judge that the black defendant should be punished harsher for a lesser crime than the white defendant. So essentially, it effectively brought historical patterns of discrimination into the future. This gets even more difficult with neural networks because neural networks are black boxes. And so AI developers often do not know what the neural network's limitations are before they deploy them into the wild. And so what that means is sometimes egregious harms happen before they identify a certain limitation of the neural network. This is the case of the very first pedestrian that was killed by a self-driving car. And an analysis found that the neural network misfired. It did not identify the pedestrian, and that's why the car hit the pedestrian. And it's because Elaine Herzberg, the pedestrian, was what AI developers call an edge case scenario. She was jaywalking, she was pushing a bike, she had just gone grocery shopping, so her bike had tons of grocery bags on it, and that had never been in the training data. But the developers didn't know that until she was killed. So let's talk about generative AI and how it relates to what we just mentioned. Where should generative AI go in this diagram? Say louder. Yes, within deep learning. So if machine learning is the subset of AI that learns from data, and deep learning is the subset of machine learning that learns from big data, generative AI is a subset of deep learning that learns from big data and big compute. So generative AI is inheriting all of the features of machine learning, which is the probabilistic statistical nature of it, all of the features of deep learning, which is the black box nature of it, and it has some unique characteristics itself. And since generative AI has emerged, some people now call everything machine learning that predates generative AI predictive AI. So you may have heard this term before. Predictive AI is not referring to something new, it's just renaming something that existed before. And what makes generative AI different from what came before? It's ultimately about where new data appears in the process of machine learning. So with predictive AI, you have your new data at the start where you're feeding it into your model and then the model is giving you some kind of prediction. And with generative AI, you have a prompt that you're prompting the model with, and the model is the one that is generating the new data. As I mentioned, these are systems that are trained on massive amounts of data, massive amounts of compute. So one of the unique challenges of generative AI is that no one knows what's in the training data that's being fed to these systems. We are talking about terabytes of information that companies are feeding into generative AI systems. They are not systematically checking what is in there. So that means that there's disinformation in there. There's factual errors, there's misconceptions, there's conspiracy theories, there's hate speech, there's science fiction, fan fiction, tweets, rants, hyperbole, racism, abuse, there's everything in there. And over the years, various investigations, over the very short 2 years that we've had generative AI, various investigations and research has shown the extent of the low quality information that is in these systems. So in 2023, researchers at Stanford found, for example, that one of the most common data sets for training AI image generators like Stable Diffusion, like actual products that have been deployed into the world, actually contains illegal material, thousands of instances of child sexual abuse material. This has also obviously resulted in this problem that we already saw with deep learning and self-driving cars. It has amplified the inability of AI developers to understand how their systems are going to act. And so there has been a phenomenon where, which Bloomberg, Rest of World, and Washington Post have really explored quite well in these stories, where these systems really amplify discrimination, amplify kind of harmful content in ways that are not really caught before the systems are deployed into the real world. And Bloomberg found, for example, that CEOs and engineers are always generated as light-skinned, social workers and housekeepers are always generated as dark-skinned, and women are consistently misrepresented. It doesn't actually reflect reality, so women account for 39% of doctors in the US in the real world, but they only account for 7% of the images generated by these systems. And of course, because machine learning is inherently probabilistic, in generative AI, that manifests in the problem of hallucinations. You may have also heard this term. It refers to when chatbots or other generative AI systems produce things that are just incorrect, which happens by their nature, not by accident. And earlier this year, Apple had a really embarrassing flub where its AI-generated news alerts contained serious errors. So it took to summarizing shooting suspect Luigi Maggioni to Luigi Maggioni shoots himself. And what was worse is that Apple designed the feature so it looked like BBC had actually written that headline. And Apple had to completely pull the feature. And there was this recent study from the BBC just released in February where they tested OpenAI's ChatGPT, Microsoft's Copilot, Google's Gemini, and Perplexity, all on whether or not it delivers news accurately. And 51% of all AI answers to questions about the news were judged to have significant issues of some form. So this is really important when we are thinking as journalists about how to use AI in our own practices. I have 7 more minutes. So we're going to dive into 2 case studies, maybe 1. So the first case study is a story I did with my colleague Deepa Sitharaman for the Wall Street Journal. And I mentioned before that one of the questions we can ask in the data column or the data part of the supply chain in AI development is who is actually preparing the data to be fed into these AI systems. And this is a question that I've personally been quite obsessed with for the last few years. And the answer is American companies will often contract workers in the global south to perform this kind of labor under really horrific conditions. And this is the story that I did for the Wall Street Journal about 4 Kenyan workers that OpenAI contracted as part of a project to build an AI model that could automate content moderation for its products, including eventually ChatGPT. And I'm gonna skip ahead a little bit. What I learned was these workers were highly educated but come from low-income areas of Kenya, and they were given this project during the pandemic where there's absolutely no economic opportunity, which is just ripe conditions for exploitation. They had no other option, so they had to take this project, even if it ultimately harmed them. And what their work was to review high volumes of text describing violent and sexual content and to label them following OpenAI's taxonomy of how severe it was and whether or not it should be allowed or not allowed. And they ended up, many of them, suffering severe PTSD from this work, much in the same way as social media content moderators. So for this story, I also produced a podcast episode, so I just want to play for you, in the workers' own words, what their experience was like. This is Alex Cairo. He was 28 at the time when I interviewed him, and he was on the violent content moderation team. Hopefully the audio works. So when you would go home at night, like what would you think about after 8 hours of reading all of that stuff?
Oh, my mental state was very bad. I had nightmares. I feared people. Maybe I see too many people coming. I see violence. If I see someone holding a fork or a razor blade, I see people cutting himself or something like that. At night, I will dream. I will have nightmares. Even I'll tell my brother, okay, just come here, sit with me like for 5 hours before I go to sleep, because I need someone to talk to before I go to sleep, because if I go to sleep, I'll start screaming or something like that. So many things are going a lot in my mind, yeah.
So what made this a good AI accountability story? It really captures and centers the humans in the story. It shows concrete harm that is happening right now instead of theoretical harms that might be happening in the future. It highlights the real mechanics of how AI is made rather than abstract metaphors or anthropomorphization. And it situates the findings in a larger context of OpenAI's work, of the AI supply chain, and also of Kenya's economic situation at the time. With that, we have 4 minutes, so I'm just gonna go to questions. But please do, if this interested you at all, please do look out for when we open source the full curriculum. We have a 6-hour version of this curriculum as well, where we get even deeper, more examples, more technical. And we will be doing it first in English, but then in multiple other languages over the course of the year. I'll start over there, and then, yeah.
I'm curious what your personal take is in the reporting and research on like XAI, because a lot of what you described about like Google and OpenAI and others relaxing their privacy concerns and AI training, I'm not sure if that's okay. Oh, I'm not sure. I'm not sure if XAI is taking those precautions, because from what we can tell so far, it's trained on X conversations and the media that's shared. What are the opportunities for investigative analysis of this platform in particular?
I think it's exactly what you said. Like XAI is not taking any precautions. I mean, if we think about it from the framework that I mentioned, data compute. I mean, like, yeah, they're completely eliminating any restrictions around privacy or consent or anything with their data collection. The speed at which XAI is building supercomputers and bypassing laws to do so is insane. And they're literally like subverting environmental regulations to erect their supercomputers. So it absolutely, that company needs to be seriously investigated, like many times over. Yes.
I wondered if, hi, Isabel Cockrell from Coda. I wondered if you had any tips on covering data centers, specifically on the ground. I read your piece about circumventing the data centers in the desert, and I've been myself to data centers in northern Sweden in the Arctic. Yeah. But I kind of get lost when I get there, because it's just this anonymous building. There's like one security guard who tries to chase you away, and then a lot of the locals don't really have a connection with the data center, again, because it's so anonymous. And I wondered how do you think creatively about covering these centers on the ground?
It's a really great question, and actually one thing that Pulitzer Center and I have been discussing is we want to create a series of trainings specifically on reporting on data centers. But I think the thing that has been most successful for me, other than just trying to physically describe, or if you're an audio journalist or a video journalist, like listening to the sounds of the data center, is to find areas where communities are actually actively aware of the data center and protesting, and going to the city council meetings, going to their marches. Yeah, that's been the most successful aspect thus far, but it's not the most satisfactory answer, because obviously there's so many other data centers that communities aren't aware of, so I would love to hear more about your ideas as well. Yeah.
Hi. So as a journalist covering AI, a lot of the time you kind of need to find harm to be able to justify the story. But with generative AI, because it's moving so fast, a lot of
the technology, you can't really you can't know how the extent to which it's being used and people are actually being impacted yet. So how do you balance that when you're choosing to pursue a specific story, and how do you like find ways to show harm?
So I think showing harm is a really great way to tell a story, but I don't think it's a requirement, in the sense that sometimes it's great to just inform the public where generative AI is being used. You know, like people should know if it's being used in their kid's classroom or at their doctor's office, just as a baseline. So that's one, and I would like start in like your own communities, like just start asking your company, ask your school board, ask, you know, your city official, your police department, just ask everyone, like, are you using generative AI? How are you thinking about this? And you'll probably discover that there's like tons of systems being experimented in real time right now. And then over time, as you write stories and kind of plant flags about actually looking into these things, I'm sure there will be tips that will come your way from people that then do experience a harm in the process and want to actually talk to a journalist about it. Oh, it's time. I will stay outside so that if anyone else has any questions, you can come up and ask. But thank you all so much for being here.